Hello and welcome to another video. In this video we're going to be going over a minimum cost for tickets. And in this problem you have planned some train traveling 1 year in advance. The days of the year in which it will travel are given as an integer rate days. And each day is an integer from 1 to 365. And you can buy tickets in one of three different ways. You can buy a 1-day pass, a 7-day pass, or a 30-day pass. So you have this array of costs. So this is the cost for 1 day, 7-day, and 30-day. And that allows you this many days of consecutive travel. So if you get a 7-day pass on day 2, then you can travel for all these days. So then the next day you would need to get a ticket on is day 9. So basically you take whatever day you're at plus the days you're traveling is the next day you would need it, right? So day plus the number of days. Okay. And so return the minimum number of dollars you need to travel every day in the given list of days. So in this example, they tell you that here's one way to do it. So on day 1, you buy a 1-day pass of cost 2. You also don't need to travel on like days that aren't in this array. So basically on day 1, you buy a 1-day pass of cost 2. Then you're on day 2, but you don't need to travel on day 2. So the next day you need to travel is day 4. So it says on day 3, you bought a 7-day pass of cost 7. So it allows you to travel these days. On day 20, you bought a 1-day pass, and then in total you spent 11. But another way kind of you can think about this is you never really need to buy on days before you need to travel, because like what would be the point? So on day 1, if you buy this, then the next day you have to buy a ticket is day 4. And so on day 4, if you buy a 7-day pass, then the next day you'd have to buy a ticket. So basically this covers all of this. So here this would be cost 7. Cost 2, and now we're at day 11, and once again we don't need to buy until day 20, so on day 20 we only need to cover one more day, so we just get the cheapest one, which is this. So that's the cost there. And then in this example, so on day 1 you buy a 30-day pass, which costs 15, and that's going to cover everything up until here, and then you only need one more day, which is the cheapest. There you go. So that would give you 17 total. So that's kind of the part of the things you have to realize, like never buy a ticket on day where we don't travel. Also, the other important thing is here you're not traveling very long. So if this was like a lot of days and these tickets were like not 1, 7, and 30, small numbers, but they were like travel for like 1,000 or 10,000, then this would be harder. But we can basically manually just go through the array. So like let's say we buy a ticket on some day, we can figure out like when's the next day we have to travel based on this array. And the way to do that is like if we have all these indices, we can just say like, well, if we buy a 7-day ticket on day 2, let's just keep going to the next index until we actually need to buy a ticket here. So like on day 2 we buy a ticket, then we'll check like is day 3 minus day 2, is that covered by our ticket still? And if it's a 7-day ticket, it is, right? So we're basically looking for the first number that's 9 or bigger, because if we buy a ticket on day 2, then we have to travel on day 9. So essentially we can just check like, okay, where's the next index we have to travel? Oh, it's right here. And same thing for 30-day. Like 30 is not a big number, so you can do the same thing. You could say like, okay, well, I'll just buy a ticket on whatever day, and then I'll look for the first number greater than or equal to 31. You could binary search this. I guess that would make it a little bit faster, but not really super necessary, or pre-compute or whatever, because 30 and 7 are just so small that it doesn't really matter. So essentially we can basically do a DP problem here. And the states are pretty basic, other than this part of like figuring out that you only want to buy on days that you actually have to travel. And then on the day you have to travel, you basically have 3 choices: a 1-day, a 7-day, and a 30-day, and you just figure out like where's the next place I'm going to next. So let's go over the 3 things for DP. So you need state, you need a base case, and recursive. And most of these are pretty straightforward, other than the thing I was saying. So state is just going to be like what day we're on. And it has to be a valid index, right? We're never going to buy a ticket on a day that's not in these days. So this day is really like the index in this array that we're on. Base case, also pretty straightforward. Just done traveling, return 0. And then the recursive is we either just buy 1 day, 7-day, or 30-day, and then the recursion there is just the cost of the ticket and then you recurse to whatever next day you have to travel to. And that's basically it. So pretty straightforward DP problem. Yeah, so you can look at like constraints and things and recognize that like, okay, these tickets are small, so I can do this kind of thing. Basically, if you had a lot more days, like I said, hundreds of thousands or something, and your tickets were bigger numbers, then you can basically binary search from whatever day you're at to figure out like when's the next day I'm gonna get to. But we don't need to do that here because it's small constraints. So yeah, so let's code up the DP there. So essentially, we're just gonna have like a cache and then normal DP problem, so we can make a cache. And it's just going to be an int-to-int cache. And that's all we need. And then we can just return the DP. So DP. So the things we need to pass is going to be like the index, which is going to be an int, the days and the costs, and then the cache. Yeah, I actually don't need to give these types. Okay. And then we make our DP function. So it's going to take I, which is an int, these two. Now we actually do need the types. And then the cache, which is a map of int to int. Okay, and then it's going to return an int. And then, so we can do the base case here. So if I equals length of days, then we're done. Just return 0. What's the problem here? Undefined I. This is just going to be 0. Okay, and then we're going to check if our stuff is in the cache. So in Go, you can actually check for something before doing an if statement. So we can just say like this equals cache I. What this basically does is, okay, we'll return true if this is in the cache, and then value will be the value in the cache. So if this is in the cache, then we, yeah. And then we actually need to give the if condition. So basically, if OK is true, that means the value's in the cache. We just return val. So pretty common Go pattern. Okay, so now we have the option of taking 1 day, 7, and the next one. So let's do the 1 day first. The 1 day is pretty straightforward. Like, we don't really have to see where we're at next. If we do a 1 day ticket, we'll just be at the next index, just because that's the next day we'll have to buy a flight or a ticket. Like, if they're 1 day apart, it'll be the next index. If they're 30 days apart, it'll still be the next index. That's going to be like our base case, or not our base case, but our first recursive case, which is easy. So we can just say result is costs of a 1 day ticket plus DP of I plus 1, and then pass down all these things. Okay. Now we have to actually calculate, like, if we buy a 7 day ticket, where we're going to be. So we can just make another variable for that. And we can just say, so there are no while loops in Go, but it's basically the same thing. You just write for instead of while. So while j is less than the length of the days, and days j minus where we're currently at is less than 7, then we don't have to buy a ticket on this day, and we can just go to the next day. So we can just say j plus plus. Okay, so that's going to calculate like where we have to be in the days if we buy a ticket of day 7. And then we can do the same thing and just max it with our old one. So I think we want min cost. So this will be cost 1 for the 7 day ticket. Instead of I plus 1, now it's going to be j that we calculated. Yeah. Let's see. Oh. Okay. And then same exact code for the 30 day. So we'll make it, this shouldn't be 1, this should be I where we're currently at. Except now the day difference is 30. So while the days is 30, same exact all this thing. And now this is the 30 day ticket. Okay, and then we cache our value. So cache I equals result and return result. And it's pretty straightforward top-down DP. Okay. And yeah, I'd probably recommend doing most DP top-down. You can practice bottom-up once in a while. So here also you can notice that you can't really space. The other thing is like, I'd probably only do bottom up if you can space optimize, and you can't space optimize because we're not always recursing to the next day. We might recurse to a day that's like 30 indices in advance. You know, imagine if we had like every day in this array, we would recurse like 30 indices. So you can't really space optimize it anyway. So top down easier. Yeah, so essentially our state is only the index, so that's just like number of days, n we'll call it. For every single one we recurse to 3 places, which is constant time. And then for all of these, we're basically only going to check 7 indices at most here, and then 30 indices at most here, so that's also O of 1. Yeah, like I said, if these numbers were bigger, I would use binary search to make this fast enough, but they're not. And yeah, so this is just linear. And our cache is also just linear because we just hold indices in the days array and the max there is 365. Yeah, I think that's going to be it. That's going to be it for this problem. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.